to look at those questions over here. Now I've compiled the following questions, the challenging ones. I want us to look at these questions here one by one in detail. Now, in the first part here, they say we are given a linear pattern, which here we have 5 and -2, -9. We've got the first 3 terms as well as the last term. The last term, guys, is equal to Tn. Okay, so you must take a note of that. So, and then in the first question they say write down the constant first difference. Of course, they just say it is a linear. All right, so that means we're going to just try to work out the constant first difference. That's all, nothing much, and it's all for 1 mark. And then the second one says write down the value of T4. Now the values that we have here, it's T1 and then it's T2 and T3, so we don't know T4. Okay, so that means we'll have to work out that part. And the last one, to calculate the number of terms. So this question is the same as that one that says which term. So when they say which term, or they say calculate the number of terms, that means you have to find the value of n. Now let's begin to look at the first part. So now, meaning that in the first question here, which is 1.1 point, or before that, let me just copy down this sequence. We've got 5 is to -2, we've got -9 is 2, and then up to the last one, which is -289. Okay, so I'm saying that this one's the same as the last term. The last term is equal to Tn, and Tn is equal to the general term, which is Bn plus C. All right, so this is T1, this is T2, this is T3, so we can find the difference between the two. Now I always advise you guys that you must use this formula here that says T2 minus T1 is equal to T3 minus T2. So it's gonna help you to get the correct answers, especially if there is one term which is negative, like for example this one here. Okay, so it's going to be -2 minus 5 and -9, negative into -2. So negative and negative must be -7, and -9 plus 2, which is -7, and we drop this one. So this one, it is a constant difference, so which is -7, -7. So we are done now, because they say we must find the constant difference in the first question. So we just say therefore D is equal to -7. So we are done in this question. And then we go to the next one. The next one says write down the value of T4. So that was 1.1.1. Now we're going to 1.1.2. So the value of the next term, it's easy, which is add, but now that there is a negative, so it's going to be -7 plus 5, which is -2. -7 plus and -2 must be, this one is negative over here. Okay, so negative plus negative, so that means going to -7, -2 is going to be -9, -7, -9, and therefore the next ones must be -16. Let me just use another color. Must be -16. So if now we may continue in that way. So that one, it is the next term. So you just continue in that way. So that means the next term, so this term here must be T4. So we simply, because it's just for 1 mark, so we simply say therefore T4, let me continue with the yellow in color, T4 is equal to -16. So we're done in this question. We go to 1.1.3. Okay, 1.1.3 says calculate the number of terms in the pattern. So just before we calculate the number of terms in the pattern, we need to determine the formula first, which is the general term. Okay, it's going to be a bn plus c. Remember, always saying that 7 is the same as b. Okay, so that means we've got negative 7b plus c, and to get c is going to be b plus c is equal to the first term. So that means b plus c is equal to the first term, which is 5. So b is negative 7 plus c is equal to 5, and that means must be and 7 there, so it's going to be 12. So therefore the formula must be negative 7 plus 12, so that one is Tn. So, and then from here, as they say, we must determine the number of terms. So it's easy. Remember the last term there, which is equal to Tn, meaning that in the place of Tn over here, we're going to put that 289 and negative 7n plus 12. And then we transpose 12 to that side and we change the sign. It's negative 289 minus 12 and negative 7n. So without any further waste of time, we simply divide by negative 7 in both sides. So therefore the value of n here is going to be 43. That is the number of terms. So we go to 1.2. So a linear pattern has a difference of 3 between consecutive terms. What do they mean when they say consecutive terms? They mean that you have maybe the first 4 terms, which they have the constant difference or the same difference. For example, we've got 1 is to 2 is to 3 is to 4 and so on, and the constant difference here is 1. So these terms here are called consecutive terms. Why? Because between the two terms, or between these terms, we have the constant difference. All right, so they say 3 now is that constant difference between the consecutive terms. So they say its 20th term is equal to 64, meaning that starting from the first part and the second one and the third one and the fourth one and so on up to the 20th term, that means it's 64, and they continue in the same way. So now they are saying to us, between these terms, between them, there is 3, because that 3, 3, 3 and 3. Okay, there's 3 wire there. So what we're gonna do is that, meaning that 3, it is the constant difference, so it's easy. So meaning that if you want to get the next term, the following term, so we simply add 3. So that means it's going to be 3 plus 64, that must be 67. That one is going to be T21. And then 3 plus 67 is going to be 70. That one is going to be T22, and so on. Same applies for T19 and T18 up to the first term over here. All right, I think now we are ready to attempt the following questions. So the first one, they say T22. We have already obtained that question. There is T22, it's 70. How do we get 70? We say T20, which is must be T20 64. We say 64 plus 3 plus 3, and then it's gonna take us to T22. Okay, so let's quickly do that one over here. So that means 1.2 is going to be 2.1. That is T22 is equal to 64 plus 3 plus 3, which is equal to 70. And then we go to the next one, which is 1.2.2. They say which term in the pattern will be equal to this value. So usually we used to be given a number when they say which term. Maybe we given 64 or maybe 84, and then we're looking for n, the value of n usually. But now in this case we're given this portion, meaning that we have to use this to get a number. Maybe we get 50, knowing that that 50 in the place of Tn, we're going to put that 50, and then we begin to solve for n. All right, so now let's check how do we then use this to get the value. Just a value, maybe 50 or maybe 40, any number. Okay, so they say that T5 over here, so we need to multiply that T5 by 3 and minus 2. All right, so that means we will have to first to determine the formula, okay, for those consecutive terms, that is from 20 up to T22. So how do we then find the formula there? So it's easy, because to find the formula in a linear, the one that is a constant difference, it is b. So that one is b. It's very easy stuff. Then now to get c, so get c, if you want, we can just subtract and going back to 1, or maybe we can use 64. It's going to be the same. So that is 1.2.2. so we can say now Tn is equal to 3n plus c, and then now we can use for the fact that T20 is given to us as 64. Then in the place of n here we can put 20, we can put 20, and then the place of Tn here, and we put at 64. So to find c, so let's do it in that way. So it must be 64 and is equal to 3n into 20 plus c. So it must be 64 minus 60 is equal to c. So therefore the value of c must be 4. So therefore Tn is equal to 3n plus 4. So from here it's easy. So to find this value, that is 3T5 minus 2 is equal to, in the place of Tn over here, this portion, this part is going to be multiplied by 3, and then we subtract 2. So meaning that in the place of before this, we're going to times it by 3, and then when it comes to 5, so in the place of n, I'm going to put 5, I'm going to put 5, and that 5 is multiplied by another 3, which is this one here, and then we just add 4. Okay, so let me just write it here. So it's going to be 3 open, that is a square bracket, so this 3, which is this one over here, the one that is a factor, and then inside here we've got 3, which is that 3 into, in the place of n, we've got 5 here, so we're going to put 5 plus 4, we close brackets, and finally we've got negative 2 there. All right, so we just work it out, and then we get the answer. So that means we're gonna get 55. So that means the value of 3 times T5 minus 2 is 55. Then now we can begin to find the value of n. So that means the place of that Tn, place of this one, we're going to put 55. All right. So what we're going to do now is that, so it's going to be 3n plus 4 is equal to 55, and then we say 3n must be 55 minus 4, which is 51, and for 3, and then we divide by 3 in both sides. Therefore n must be equal to 17. So that one, this is the final answer. And then we go to 1.3, consider a quadratic pattern 5, 12, 29, 56, and then write down the next two terms. So let's begin to copy them down as they are. So that is in 1.3 we've got 5. Oh, we've got 5, 5, 12, 29 and 56 and so on. So it's easy, like I showed you in the previous example, how to find the next term. So I'm going to say T2 minus T1, T3 minus T2, we subtract, and then we subtract. So 12 minus 5 must be 7, and 29 minus 12 will be 17, and 56 must be 27, and then we subtract. The difference must be 10 and 10. So this is the first difference, and this is the second difference. And then how do we get the next term? It's easy. So the next term, it's very, very easy stuff. So we're gonna just say 10. So 10 plus 27 definitely must be 37, and then 37 plus 56, so must be plus 56, it should be 93, and then we continue in the same way. So must be 10 surely, because it's the second difference. So 10 plus 37 must be 47. 47 plus 93 must be 140. These are the next two terms. So you always, this one 10 plus this, and 37 plus 56, and 47 plus 93, and so on. So it's easy like that. And then we say, therefore, in 1.3.1 we've got 93 and 140 as our next two terms. Now we are done in that question. We go to question number 2 quickly. Question number two, and then in that question number 2, what we're gonna do, we're gonna just copy down the quadratic patterns, which we've got -1 and x and 3, x and 8. -1 is 2x, 3, and x plus 8. Let me just make sure that everything is correct. Oh, it's x plus 8, perfect. Then we need to calculate the value of x. That's wonderful. This is a nice question. So we simply find the constant difference. It's going to be x minus 1 and 3 minus x, and x plus 8 minus 3. We always subtract. All right. So it's going to be x minus 1, which is x minus into 1, which is going to be x plus 1. All right. So that means it must be x plus 1 here. 3 minus x, which is 3 minus x, and then x plus 8 minus 3. So this is what we have as our first difference. Then we go to the second difference. So must be this one minus this, and this minus this one. It's always like that. So must be 3 minus x and minus x plus 1, and then say this minus this one. So must be x plus plus 5, and then minus, because 8 minus 3 is going to be 5, and then minus into 3 minus x. So this is our second difference. So now, in order for us to find the value of x, it's easy, guys, because we know that the constant difference is the same. So I'm going to say this is equal to this one, and then we solve for x. All right, so we'll say, because they are the same, so it's going to be negative, which is 3 minus x, and then we open these brackets. So let me just drop it as they are, and just copy down everything here, just before we do anything. Okay, now we can begin to work it out. So 3 minus x, so negative times that, minus x and negative 1, and x plus 5, negative times that one, minus 3, and plus x. We collect like terms. So on this side we've got negative x, which is this one. Okay, and another one, negative x. All right, so we're done with x's now. So we go to 3. So on this side we've got 5, we've got negative 3, we've got 3, which is positive, become negative, 1, which is negative, become plus, and then 3x and x, 1 2 3 must be negative 4x, and 5 minus 3. The answer should be 5 minus 3 must be 2. Let's say negative 1 and negative this one must be 4. The answer is going to be 6, and plus 1, 6 is going to be 6 minus 6, so which is 0 on the side for negative, and then divide by negative 4, and therefore x must be 0. Okay, so that means in the place of x over here it is 0, so it is also 0, 0, 0, and 0. Okay, so we're done in this question, and then going to the next one. So the next question we are required to let me just check this one. So show that the nth term of the pattern can be written as this one. Okay, that's perfect. So that means in order for us to determine that or show that, we will have to that was 2.2. Okay, that's perfect. So this is gonna be 2.2. Let me use the same color, 2.2. So we need to show this. Let me just write it down. N minus 1 all squared, and minus 1 or plus 1. Let me just double check that. It's going to be negative 1. Okay, so in order for us to be able to prove or to work out this, so we have to we substitute 0 in the place of x there, and then we start afresh. So negative 1 is to 0 is to 3, x plus 8, which is just 8, and then we find the constant difference. So that means it's going to be 1 minus which is 0 minus 1. It's going to be just 1 and 3 here. 1 and 3, and the 8 must be 5. Okay, which is x plus 5, which will be just 5 here, and then we continue. Of course, it's going to be 2, the constant difference. Okay, so now we'll have to determine the quadratic equation, which is that one, tn is equal to an squared plus bn plus c. We have to determine the values of a, b, and c. All right, a, b, and c. So let's go. Now this is the first difference. This is the second difference. So we use this one and this one and that one. This is the first term. So that is 2a is equal to second difference, and then 3a plus b is equal to the first difference, and then must be a plus b plus c is equal to the first term, and then must be 2a is equal to that is 2, and then we divide it by 2 in both sides. Therefore a must be 1, must be 3 into 1 plus b must be 1, and then 3 plus b is equal to 1. Therefore b must be 1 minus 3, which is negative 2. All right, which is b. And then 4 must be 1 minus 2 plus c is equal to negative 1, and then c must be negative 1 plus 2 minus 1. so that means C is going to be 0. So therefore in this equation must be Tn is equal, the place of n must be just n squared and then negative 2n plus 0, which is C. So we have to prove this now. Okay, so in order for us to prove that, it's easy. So we're going to say n squared minus 2n, and then we know that 0, we know that plus 1, let me just use another color, we know that plus 1 minus 1 is going to give us 0. Okay, at the other side, we know that we can factorize this portion. So how do we then factorize this? So it's going to be n on the side and n here, 1 and 1, negative and negative, and there's that negative 1 over there. So yeah, so then from here we can see that we have two brackets which are the same, so we can say this is going to be n minus 1 all squared, and we throw this negative 1 over here. So we've got Tn here. So let's check what we are proving here. Open brackets and negative 1 all squared. So this is what we've got here. So that's perfect. And then we go to another one. So they say calculate the value of 65th term of the pattern. So it's simply we use the same formula, and then to get that value in the place of n, we put that it must be 2.3 if I'm not mistaken. So we use the same formula, that is n minus 1 all squared minus 1. In the place of n we put 65, and then just like that, and then we work it out, we get 4095. Yeah, that's perfect. And then we go to the next one, that must be 2.4. What is the value of the first term of the pattern that is greater than 9800? This one, it's easy. So we say 2.4, we are using the same the same equation, but now we'll say it must be n minus 1 all squared minus 1 must be greater than 9800. All right, so it's quite clear that we have to solve for n here, so we can just work out and multiply out these brackets. So it's going to be n squared minus 2n, and then minus 1 minus 9800 greater than 0. And then so what we're going to do is that this one portion must be f plus 1 minus 1. Just start afresh, n squared minus 2n, and then plus 1 minus 1 minus this one. All right, and then we can see that these ones here, they nullify each other, that is negative plus 1 and negative 1. So we are left with n squared minus 2n negative 9800, and then greater than 0. We factorize this, so it's going to be n and n. The factors of 9800 must be 98 times 100. It's going to give us 9000. So this one must be negative and this one must be plus. And then we say therefore the critical values must be negative 98, or which is around must be 100. Therefore the number of terms can be negative, therefore n is greater than 100, and therefore the number of terms, since they say we are looking for the first term, so we can just add 1 for the first term. That means 1 on top of 100 must be 101, the number of terms. And then the next one says question 3, we're given those portion here, so we have to find the value of p. So this one is easy, so we just copy down as everything as it is, and then we just work it out, this question here, which is question number 3. question number 3. So in this question here, so what we're going to do is that when we work out these questions, so we're gonna, so let's just copy down everything as they are. Because we've got 1 minus p is 2. So in this question we're going to use that formula, okay, for constant difference, because it is a linear. So we're going to use this one, that is t2 minus t1 is equal to t3 minus t2, and then this is t2, this is t3, this is t1. So that means going to be 2p minus 3, and minus for the formula into 1 minus p, and then t3 of course is plus p plus 5 minus into 2p minus 3, and then we're going to have 2p minus 3 and then negative 1, and then plus p is equal to, must be 5 plus p, and then it must be negative 2p and plus 3. We collect like terms. We've got 2p on this side, we've got plus p on the other side, so we transpose this one, we change the sign, because negative p, we transpose this one, become plus 2p is equal to, so on that side, on this side we have 5 plus 3, which is this one, and then we transpose negative 3 to that side, become plus 3, we transpose negative 1, become plus 1. So now we just work out this, so this will nullify this, therefore 2 plus 2 must be 4p is equal to, and then on that side we've got 5 plus 3, which is 8, and then 8 plus 4 definitely is 12. We divide it by 4 in both sides, therefore p must be 3. All right, and then the next question, in question number 3, the next question says, the next one says the first term of the pattern, that means t1, okay, first term, and the other must be the common difference. So the first term, it's easy. Now that we do have the value of p now, so that was 3.1 and 3.2.1. so the first term is going to be t1 is equal to the first term over here, it's 1 minus p, so it's 1 minus p. Now we've got the value of p here, so it's going to be 1 minus 3, which is negative 2. Simple as that. So we check the next one. So the next one says the common difference. So the common difference, so in order for us to get the common difference, we have to find t2 first. We have to determine t2, because now we do have t1 is negative 2, but t2 they still have that p, which is unknown. We have to substitute with 3, and then we see what do we have. So that means in 3.2.2, so t2 will be 2p minus what? Minus 3. Minus 3, and then we just work it. 2p is 3, and then minus 3, so that must be 6 minus 3, which is 3. Okay, that one is t2. So now that we do have t2 and t1, so the constant difference, now it says must be t2 minus t1. So t2 is 3 and t1 is negative 2, so that means the constant difference is 5. All right, so we are done with this question. What else now? Oh, the last one. The last one says explain why none of the numbers in this linear are perfect squares. Explain why none of the numbers in this linear are perfect square. So we need to explain that part. So firstly, let's just determine all the terms here by substituting with the value of p. So then we see what do we do after that. Then what we're going to do is that, so in the last question, that must be 3 point, and that must be 3.3 if I'm numbering correctly. So what I'm going to do is that in the first term we've got -2, second term we've got 3, and the other one should be because we've got the third time it's p plus 5, which is 3 plus 5 must be 8. So, and then we've got 8, and the next one, because the difference, remember it is a linear, so the difference is 5. So you say it's 5, because it's going to be 5 plus 2 must be 3, and 5 plus 3 is 8. So it's going to be 5. Also 5 plus 8 is 13, and it's 5 also, because they say it is a linear and must be 5 plus 13, it's 18, and so on. So we say now in this case all the terms except t1 and in either a3, that means except t1, right? So in the a3 or 8. So, and then while perfect square end on 0, 1, 4, and then 6 and 9. So these are the perfect squares. So we say therefore all their terms, okay, all the terms except t1 and, so the and in either, so and either a3 or n8. Okay, while perfect square, perfect squares, and on 0, that is 0 and 1, 4, and must be perfect square. Let's say 5 also, because 5 come from 25, so it's 5, and 6 from 36, and 9 from 81. So from 9, yeah, that is the perfect part. So we're done in this question. So now let's look at another one, that is the last one, question 4. Given the 10, 7, 4, 1, we need to write down the next two terms. Okay, 10, 7, 4, 1. So let's check how do we then go about answering this question. 4.1.1. So must be question number 4. Question number 4. That is 4 point, or before that, then we've got 10, 7, 4, and 1. So, and then the first question they say we need to determine the next term. So first, before that, we have to consider the difference first. So t2 minus those must be -3, and 4 and 7 is -3, -3. All right. So this is a linear, of course. So that means in order for us to get the next term, was -3 plus 10 must be 7. Negative plus 10 plus 7 must be 4. -3 plus 4 must be 1. And then what will be the next? -3 plus -3 plus 1. -3 plus 1 must be -2. And then we continue, -3 plus -2 must be -5. Right. So therefore in the first question the next two terms are -2 and -5. So these are the next two terms. And then now we look at the next question. The next question now says we need to determine the formula of the nth term. Well, this one is easy. So to determine the formula, this one, which is the b, that one is going to be b plus c is equal to the first term. So it's easy. So the formula says Tn is equal to negative 3n plus c. To get c, it's b plus c is equal to first term. It's negative 3 plus c is equal to 10. And then c must be 10 minus or plus 3. So c must be 13. And then we come to to this one, and we substitute, must be 13. So that one, it is the nth term. So the next one says which term of the sequence is equal to that is 4.1.3. so when they say which term, that means we're looking for n, and therefore Tn will be negative 179. So we'll be using this formula. All right, so that means going to be Tn and negative 3 plus 13, and must be negative 179 and negative 3n plus 13. And then I just transpose this one to that side, so become negative 179 minus 13 and negative 3n. So which then is going to give us 10, and must be 8, and 1 must be 90. So must be negative 192 and negative 3n, and then we divide by negative 3 and divide by negative 3. So therefore n must be equal to 64. All right, so we've done in this question. Is there any other question? Let me just double check that. So we've done with this question here, or the last one. Again, we need to solve for x. All right, so we've got 3x minus 2 and x plus 9. So let's just copy down all those terms that are given to us, and then we begin to solve the last one. I think that must be 4.2. Yeah, so we are given that 3x minus 2 is 2x plus 9, and then is 2x plus 5, and then so on. It's easy. This one is T1, T2, and T3. So we just use the formula, that is T2 minus T1 is equal to T3 minus T2, and then we just substitute. So therefore T2, it's x plus 9, and then 3x minus 2, and then must be 2x plus 5, and then must be x plus 9. So must be x plus 9. We just work it out. Open these brackets with a negative sign. Must be plus 2, and then we drop those ones as they are. Again, we open up brackets with a negative sign. Must be negative 9. So we collect like terms. So we've got x on this side minus 3x, and we transpose this one, become negative 2x. We transpose that one, become plus x is equal. So on this side we've got 5 minus 9, and we transpose 2, become minus, transpose 9, become minus. All right, so finally, so this one over here, x plus x must be 2, so this will nullify with this one. We're left with negative 3x, so is equal to, so on that side we get negative 15. We divide by negative 3 in both sides. The value of x must be 5. Simple as that. I think that was the last question. Let me just confirm that that was the last question. The value of x therefore here, x is 5. So thank you so much for watching. Thank you so much for watching. I hope you understand now this question. If you've got a question, you can just up the question in the comment section. Thank you so much.